Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, Using Machine Learning and Artificial Intelligence for Modern Software Delivery, brought to you by Harness. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to watch it. It will be available for on-demand viewing. We will be sending out a link to access the webinar on demand, or you can visit devops.com/webinars, and it will be available for you as well. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab. Let us know your thoughts, or just say a quick hello. We also have a polling question during today's event, so we'd appreciate if you could take a couple of seconds to submit your answers when you see those come up on your screen. Finally, stick around until the end because we are doing a drawing for four $25 Amazon gift cards, so stay tuned to see if you're a winner. Joining me today is Nick Durkin, Field CTO, Harness. And with that, I'm going to put myself on mute, turn off my camera, and let you get to it.
Awesome. Well, genuinely, thank you for having us this afternoon or this morning. And ultimately, like the slide says, want to talk about machine learning, artificial intelligence, and software delivery. And I think it's quite amazing. My background comes from building machine learning models for the banks. And at Harness, I was in play number 9, really kind of crafting a lot of our product early days and now owning our pre-sales and post-sales engineering efforts. When we think about machine learning, when we think about AI, this scares a lot of folks, and it always gets quite interesting. A lot of people think about removing people's jobs and taking that away. And I think if we look at even how we used mechanical muscle in the early 1900s, we never took away jobs, we just upskilled everyone. And I think really that's the goal when we're talking about machine learning, when we're talking about artificial intelligence and software delivery. It's removing all those extremely painful pieces of the job that no DevOps, no engineer wants to handle. And I think that's the interesting part. It's not removing jobs, it's removing the most annoying pieces of it. I'll give you some examples and we can go through this. Keep the chats rolling if you guys want, by all means. I'll try to monitor them the best I can. I have to do 2 screens and figure that all out, but absolutely keep them going. So when you think about AI and you think about ML, I like to think about it as enhancing lives, not actually hurting them, right? But I do want to ask some questions, like who absolutely loves, in every way, shape, or form, dealing with war rooms and dealing with babysitting deployments, right? This, to me, is absolutely one of the most wasted times. It's astronomically expensive for resources. No one likes being up at 3 o'clock in the morning. This is broken, but you know what? We do love the free pizza, right? So best case scenario, war rooms, free pizza. And I guess there's some upticks to that. And if you think about it, if we do the same things like feature flags or database toggles, we might be able to make smaller changes, but ultimately at the end of the day, we still have people sitting around looking at a knock, trying to figure out if our change was okay or not. And it's a waste of our best engineers' time. The reality is there's much better things for them to be doing, right? We also still love the free pizza. And, lastly, when you think about it, when it comes to builds, right? Just even doing continuous integration, I can't tell you how much I absolutely love just waiting for tests to run. I've got 3,000 CI tests or 3,000 unit tests I have to run. I've got to do my integration tests, all the fun pieces, but I just have to sit there and wait for them to run on really expensive infrastructure. I do love all the coffee breaks, however, great benefit, I guess, when we come down to it. But ultimately, these are the most annoying parts of our jobs. And the reality is, let's go and remove those annoying pieces so we can actually upskill and uplift. So let's use AI and let's use ML to enhance, right? Not to replace. So I want to talk about a few different things. We'll talk about CD. We'll also talk about CI in the end of this. I'm really going to talk about how you can leverage AI and ML to, again, make lives easier. And so we're going to talk about change orchestration, actually understanding what's changed, how it's changed, and understand what to do with it. And we'll walk through some of this and how it's done. I actually like to make it akin to something that we all maybe know about. And if you don't know about F1, that's fine. I think we can have an understanding once we start walking through this. You probably know about cars. And really, I want to make this an understanding of how this compares to what we do in software delivery and what they're doing actually to be a lot better at it than we are. And then we'll try to figure out how we can leverage those same technologies to actually impact our software delivery. When you think about it, when you build one of these cars, there's literally 100,000 components, and there's 100 engineers working on this. Let's say each engineer only made one tiny little mistake, right? If we had 99.9% of it assembled correctly, we still have 100 points of failure that you would have. So this is where it gets massively complex, and this is where it draws some similarities with code. You know, if you're going to win in Formula One, the whole benefit here is that you get brand recognition, right? We're going to win races. We're going to actually make sure that our cars are fast and that we're actually reliable, because we only have a certain amount of engines we're even allowed to use. And the ideas and innovation have to keep flowing because we have to stay ahead. And really, this is all about continuous delivery, right, of a product and time to market. I have to be able to do this between race to make sure that I'm faster than my competition, right? Our engineers, our chief engineers, have the same problem that they do in F1. If you think about it, change is constant. It is always being changed. We're always making modifications. We're always doing this. And the reality is these engineers have to deal with 50 brand new parts every single race. How do we know what they're doing? How do we understand what they're going to have effect on? This is where it gets complex. And so a deployment pipeline for F1 is a little different, right? We got to build it up in CAD. We're going to send it through a wind tunnel. We're going to simulate it. We're going to run some models against it. We're going to literally install the part, right? And then instantaneously, we're going to get telemetry back, and we're going to understand what we've done to the metrics. And if it didn't work, if it didn't improve the lap times, if we didn't get the extra downforce, we're going to roll back. Right? This is interesting, but it's also akin to software delivery. We do this a lot today, right? We'll do our builds, we'll do our tests, we're going to deploy out. When it gets to the customer, we're going to verify with a multitude of tools. And then, God forbid, it breaks. How do we get back to where we were before we started? Right? This becomes a huge problem, and it can take a massive amount of time. So what's the big difference? Well, if you think about it, every single team knows exactly what they're modifying and exactly what they're going to get from it. And they verify that impact instantaneously. They know that when the car goes out, so they know we're going to have roughly 2 seconds faster by the end of the season. And these are the types of things that you can do when you apply continuous verification, right, in real time. Testing and verification is critical. This is, again, whether it's a car or whether it's software, right? Measuring that impact becomes even more important. Sure, great. How was it? But ultimately making sure we know how we're doing in comparison. And this is where that telemetry becomes interesting. Right, when we think about it, we've got this idea of automation. We have this understanding that feedback is king. We've got all the metrics coming in, all of the pieces there, and we're literally using data science in real time to understand what this looks like. Well, why in the heck don't we do this same kind of verification for our software? We should be taking and understanding what this looks like in production, what this looks like in QA, and making the understanding and the comparison to know if we're better or if we're worse, and do it right away. And invoke a failure strategy. So get back to where you were before you started, hopefully without you having to write a single line of code. All right? For a lot of people, deploying applications is not that easy. Some of us have automated this, and we're doing canary deployments. Maybe some of us are doing blue-green, but for a lot of us, this is still a very manual process, massive in committee, right? Dealing with a lot of different pieces, and it's traditionally a very large deployment, right? Where, God forbid, something breaks, it's catastrophic, right? And we have to get back to where we were. And verifying that things are good, whether it be in software delivery, or whether it be in actually just toggling a feature flag for customer, a database toggle, this becomes kind of hard to verify. There's not enough people looking at the screens at a knock to understand what good looks like. There just physically isn't enough. If we want to reach our velocity metrics, there's not enough people to do it. And so the problem is hey, it's working and it looks fine, doesn't work anymore. Right? Now we have to start moving at the speed of our customers. And that, unfortunately, is faster than we can sit there and look at a knock. When we think about continuous delivery, when we think about getting to the endpoint that we all kind of want to, it really requires automating everything. And this is from dev, from the initial builds to the tests, right? This is in QA, doing all of our separate tests, our security gates, our quality gates, our performance tests, and then ultimately getting into production, making sure this is deploying accordingly, that it's verifying that it's actually better for the customer. And we think about it, it's truly not just code to production, but code to customer. And this is where it matters, because if you deploy it to prod and it's bad, right, it doesn't actually mean that you've deployed successfully. But the only way you do this, right, the only way you can truly achieve this at scale, right, is using the machine. And I say this because humans are great at a lot of things, but they're not great at everything, right? So this is the part and piece where we have to leverage and we have to rely on machines to do a lot of the thinking that we used to. Because honestly, like I said, who loves babysitting deployments? Nobody, right? Machine learning isn't necessarily a silver bullet either. right? This is not necessarily the one thing that's going to cure everything for the rest of the world. However, it does, like I said previously, it does do a lot of things better than humans, right? When we think about it, we'll go over some basic machine learning 101 because a lot of people talk about machine learning. A lot of people talk about artificial intelligence and neural networks, but the reality is a lot of people also falsely advertise it. So let's understand what it is so we know how to leverage it and we know where we can use it. When we think about machine learning, we think about unsupervised machine learning. And this is the cool part. This is where I let the computer tell me, right? I take things like natural language processing. I take the idea and understanding of allowing the computer to give me its own view. Think about having a new person come into the company and take a look at everything you've been doing with entirely open eyes, right? I'm giving it no context that I have previously to be able to understand what this looks like. Now I can create neural networks. I can create an understanding of what normal looks like based on the machine's ideas and the machine's ideas alone. And that might be perfectly fine. But there's some times when we want to actually inject what we know and our experiences into those models. So when you think about it, say supervised machine learning, this is where we actually start giving feedback. So giving neural feedback is the ability to allow that model to become smarter, to use the context that I have or that the individuals have to be able to add that to the machine learning model. So as I see things that I like, allow it to know that. If I see things that I dislike, also allow it to know that, and really start forming what normal looks like. What's interesting, and this is what a lot of people talk about, oh, we've got machine learning and we do all of this. And the reality is, you know, what they mean by machine learning is regex, thresholds, if it exceeds or if it goes under, you know, standard configurations or genuinely, you know, things like standard deviation. That's not machine learning, that's math. And math is great. There's nothing wrong with math. It's just not machine learning. And so the idea here is that, again, we want the machine to constantly grow and get better at it, the same way our human brains would, the same way our best engineers would. If you think about it, with our hardest problems, we don't call our newest engineer to go look at it when there's an issue in production. We call the person with all of the context and the understanding who's seen it time and time and time again, who can quickly remediate and quickly understand what it looks like. This is where machine learning can be used in the exact same context. So how do we do this, right? How does Harness do this in our capacity, in our tooling? And if you think about it, I want to look at all the metrics that you care about, right? I want to look at your APM metrics. I want to look at your performance metrics. I want to look at your logs. Look, if our CloudWatch metrics or our App Dynamics or APM metrics are slow, the first thing I'm going to go do is look at my logs. Well, why don't we look at those while we're doing the same thing? And what about your custom business logic, right? We have a lot of retailers that love to look at, you know, again, their performance data. They love to look at their logs when they're deploying, but also they look at very specific custom business metrics. So they look at things like, for instance, a percentage of people who put an item into their cart and then check out, right? This is a very good example of a custom business metric that can be used in the same capacity as other performance metrics that we have. And the idea is that if we do see anomalies, the intention here is to give you the ability to invoke a failure strategy. Well, what do I want to do? Right? If my metrics that are key, my golden metrics, are massively impacted, maybe I want to roll back, get you back to where you were before you started without you writing any code. Or maybe if the logs are looking funny, I want to alert the individuals. I want to show them exactly what's wrong with it, what we see as a difference, so that they can hone in on exactly where we're seeing the problem, and they can make a manual determination. Do I want to continue forward? Do I want to abort? Do I want to roll back? Do I want to retry? Do I want to inject a new task? All these are here for you, but ultimately gives you the full ability to entirely automate not just what happens upon success, but also what happens upon failure. And this is extremely important. Happy path is great. We all love what happens when we move forward. The problem is that's not the times that make us, you know, that we spend the most time upset late in the evenings sitting in those war rooms. It's actually when it's failure. And those can happen at any time. And being able to automate not just what happens upon success, but more importantly, what happens upon failure is ultimately what's going to free up that opportunity and free up that time for our best engineers. So how do we do this, right? Because we're going to get nerdy. Hopefully we're good with nerdy. If we're not good with nerdy, you can put it in the chat. You can let me know. And let me go make sure I'm actually looking at the chat. I think I'm missing it. There's a lot here. So greetings from everybody. Thank you so much. We got people from all over the place. It's late in the Swiss Alps, so thank you. And Zimbabwe, wow, awesome. All right, so the context matters, right? What we're comparing matters, but most importantly, we have to think about how we're going to do a comparison. And it's going to be different based on what type of deployments we do. So if you think about it, if we do, let's go with a canary verification. So if I've got a canary, canary deployment being I'm going to take what's currently running in production, I'm going to stick a small subset of what's running in production. I'm going to stick a small subset of a brand new instance of that, and I'm going to test that with live data side by side. Well, that's easy, right? I've got two versions running live side by side in production. So I can test them in real time as they are in production. And I can make a comparison. And at that point in time, my control data is the initial or the original application version, right? And the test data is coming from that new canary version, right? And I'm going to go and I'm going to compare those two live. Where this gets interesting is what if we want to do this in, say, QA, right? In QA, we have to do this differently. And again, your best engineers would think about this. They're not going to compare it live in a canary verification. What they're going to do is they're going to compare it against that last load test. Whether that last load test was 5 minutes ago, whether it was 5 weeks ago, 5 days ago, 5 months ago, it doesn't really matter. I want to make sure that I'm better in every capacity than my last load test, right? Or if I'm not better, at least I'm the same. And so again, the control data becomes the last time we ran that test, and the test data becomes that new version, so I can compare it. And this is where it gets interesting, is that let's say we do canary, right? That's easy. We do the previous analysis, but what happens when we do blue-green? Or if we do traditional deployments, which take an outage? Well, now we have a problem, right? Now our brains don't have a problem with this, but machine learning has a problem with this. So what's the problem? Well, the problem is I don't have two versions live side by side. So I can't run a canary analysis. And last time I checked, your production data 5 minutes ago doesn't look like your production data 5 minutes from now. So I can't use a previous analysis. So now I'm stuck. And this is where, just like your best engineers, we have to build predictive modeling. We have to understand what those fluctuations look like in your daily behaviors to understand what normal looks like in the capacity when you deploy. And so now, depending on how you're deploying, what you're deploying, where you're deploying it, in which environment you're deploying it, all determines what kind of control data we have to use to then test it up against. Now, humans can do this automatically, but unfortunately, you have to train a machine to do each one separately for all the different permutations. And then you can allow it to start learning as we see better and better deployments. When we think about performance anomalies, this can come from a multitude of different tooling. Here's some examples. It's not an all-inclusive list, but the reality is we're going to pull data from time series-based output, whether they're APM tooling, whether they're from your cloud providers, whether they're native to your infrastructure. We want to pull all the data that's meaningful to you, that you use. And we also want to take in all those custom business metrics to be able to make that decision the same way your best engineers would. And this is the key part, right? This is what has to happen in order for it to start thinking and having the models work like your best engineers. So how do we do this? Right? When we go and we do a complex deployment for you, right? You don't have to write complex deployments in Harness because we know how to do complex deployments to all the different infrastructures. You tell us you want a canary, you want a blue-green. Your engineers don't even have to know they need a secondary route for a blue-green, right, for their staging route. We'll handle that for them. And then we can go and verify with all the different tooling that you have. Now, what you'll find here, right now, my 95th percentile response time, I've got some latency issues. My brand new version is actually getting quite slower than my original. And if this were the case, right, what would our best engineers do? They'd probably go look at the logs, take an idea, see what's going on, see if they can tune it. If not, let's get it back to where it was. Or worst case, maybe we have to fail forward. But again, I only want to be alerted when there's actually a reason to be alerted and to be understood. And so now I can make those comparisons for you automatically, so you're not sitting there babysitting those deployments. We're not sitting in a war room waiting for this to complete. You will notice, however, that upon failure, this did fail. We didn't like that it failed, and we used our default failure strategy, which was to roll you back to exactly where you were before you started, without you writing a single line of code. Right? This is because we know what you deployed, on which infrastructure, with which configuration, and which secrets, so we can always get you right back to where you were, again, without you having to write a single line of code, using all the metrics that you actually care about, and only those metrics. So how do we do it? Right? Because we got to do modeling, got to do some cool stuff. I figured I'd just give you the secret sauce and we can talk about it. And if you guys have any questions, like I said, I was going to get nerdy, so here we go. All right, we're going to go through a few of the models that we use in each type of different verification to talk about it, and we'll kind of go through that. If you guys have any questions, put them in the chat. I'm checking it out. Also, somebody from Macedonia, so greetings there as well. So one of the ways that we do this is what we call symbolic aggregate expression, or SAX modeling. And what this allows us to do is really understand deviations over time and kind of group them in coordinates to understand how far off any given point and peak is. And if we looked at this without context and understanding, we would very quickly see that we've got some areas here, right, that we're showing massive difference in what we should see and what we actually see. And this, if we're doing, say, a previous analysis, where I know what that load test is going to output every single time, will make perfect sense. And I could, with certainty, say, hey, there's difference. Here are the differences, and this is fine. However, I need to use some of this data, especially if I'm going into more predictive modeling or modeling that's going to take into account that, again, traffic can be different at different times. This model alone couldn't actually meet it. This model allows you to take and aggregate and really enumerate the differences and the distances between any of these pieces. What we think about it then is now we have to use something else. If I want to actually understand what this looks like in a predictive modeling fashion, if I want to apply better intelligence to it like a human, I have to actually start building some Markov models. And the Markov models, hidden Markov models, are really going to help you in understanding what would normal behavior be. Here's a very basic one, just to give you guys kind of an idea. And it's not very accurate, unfortunately, because I live in Phoenix, Arizona. And if you know anything about Phoenix, it's extremely sunny. So this one, however, says that right now, about 60% of the chance where I'm at, it's going to rain, right? And when it does rain, I think it's showing me right now that apparently, if it's going to rain, I'm going to go clean with the highest percentage, about half the time. I'm going to go shopping, which if you know anything about me, I hate shopping, but apparently I'm going to do that. And then ultimately, because it's raining, I'm probably not going to go walk. So there's only a 10% chance that I'm going to go walk. And what this allows us to do is really take that understanding of what would happen under normal conditions if we see these. Right, now we can start applying those. And what this allows us to do is actually start taking some of that data that's either incomplete, that's out of order, and now start placing it in order again and reorganizing it to make sure that it actually makes sense with what we know. One of these given models itself will not give us an output in the same context that a human would. But if we go backwards, and I'll back it up, if we take that same Markov model, we understand that, hey, even though these are high in peaks, if we reverse them, now those peaks no longer exist. And we can actually take the Markov model to understand what normal looks like while giving it the SAX modeling to understand that we are okay. This is a normal behavior, right, based on the type of modeling that we're doing. And so depending on exactly what type of models we're doing, depending on all of that context that we needed, that's what's going to determine the modeling and the percentages and the weighting that we use for any of our given models. All right, that was for all of the event data. That was for all the performance data, for all of our time series data. The next one that I have to talk about is around log, right? Log sources or really event data. And again, you know, I've just put up a few kind of your basic ones that I think everyone's aware of. We want to be able to aggregate event data. We want to be able to analyze it in the same capacity of our best engineers. And this becomes difficult, right? It really does. So, ooh, I wonder if I can put up a poll. I might have to write it, but let's see. I'll just do it right now. Maybe I can. New poll. I'm going to type it out. So, who can sift through, what is it, 100 gigabytes of data faster? I'm really slow typing. The machine or a human? Sorry for doing this on the fly, everyone, but I figured this would be fun. So I'll get some responses. So machine and human. Hope I spelled everything right. I'm just saying start polling. Yep, we're going to start that poll. I didn't even capitalize things. All right, I got a poll out there for everybody. Hopefully we're engaged enough. If we had to sift through 100 gigs of event data and logs, looking for one individual piece, who's going to do that faster, the machine or a human? I want to meet the Superman that can grab this and do this faster. And I'll tell you what, some of our best engineers are like Superman, but we're getting a massive amount, as you can imagine, for the machine. And the thing is these are those things that we know and understand in our brain that machines do better. And this is where we want to empower those machines to do it for us. Thank you all for who actually put in the poll. I genuinely appreciate it. We're getting tons more responses, which is awesome. We're wildly, of course, heavy on the machine. So thank you for that. Sorry, it was kind of last minute, but I figured it'd be fun. Keep you guys at least a little bit engaged. So how do we then do this again, right? When we think about it, after we saw those performance anomalies, our best engineers would probably go look at those logs. And they're going to look at it with the same context that, they're going to look at it, and they're going to look at it with all the context that they have. So if we have our best engineers on this, they know what was deployed. They know the common errors they always have. And this becomes interesting because they kind of build a baseline in their head of like, yep, I see that exception every time. Don't worry about it. Don't worry about it. Don't worry about it. And that's what we're doing. So we're taking these gray dots and saying, yeah, we see this all the time. Don't worry about it. And then when we see them during a deployment, we mark them in blue, like, yeah, guess what? We saw them. We expected to see them. This is okay. But what happens if you get a brand new one, right? What happens if you get one introduced for the very first time? Or what happens if you see one that actually increases in frequency? But this is really hard for humans to see. Humans are great at understanding differences, but even, am I seeing it 3 events a second? Am I seeing it 30 events a second? Am I seeing it 300 events a second? That becomes kind of hard. And these are the types of things that people want to know about. And it's not just knowing about it, but it's also then being given the ability to interact with it, to give it neural feedback, to make it smarter, right? If I see one of these exceptions and I'm like, ooh, you know what? It is new, but I see it all the time. I know what we did there. It's not a big deal. I can make it smarter. I say, hey, this isn't a problem. Or conversely, what if this is new and we need to fix it? Now I need to create a JIRA ticket. Now I need to actually go and give people all the context of what was deployed where, when, how, on which infrastructure, with which configuration, and which secrets. And now Harness has all of that here for you. So you don't have to go and recreate the wheel. You have an audited output of everything that happened in that deployment, and you can start taking action. The idea here is, again, using the modeling to operate and think about deployments the way your best engineers do, so they don't have to sit there and babysit deployments, because we know that's their favorite thing. And also giving people the ability to make the machine learning models smarter and start thinking about it the same way that we do, right? These are the important pieces. I'll give you 2 examples. These are actually pretty crazy. This happened in our own infrastructure. So the one on the left is quite rare. This does not happen very often, but you'll see the massive amount of reds. Why did that happen? Well, this one happened actually because we broke our authentication mechanism. And the way we look at this, again, in context, is we understand where in the application it can happen, as well as what type of exception it can be. And the same exception happening in different locations in different parts of the application is a valid different exception. The same way that different exceptions in the same exact part of the application are also different exceptions. And so again, we have to start thinking about exceptions, again, with context to the human understanding of what that application looks at. So on the left, literally, when we broke one tiny piece of authentication, it broke it everywhere, right, throughout the entire application. On the right, however, kind of what happens more normally, I think this one was just a brand new feature that we released. And unfortunately, some of the classes had some issues, some NPEs and some other things. And again, we were very quickly able to understand that these, although they were similar, right, to what we'd seen before, the velocity server had increased, or we saw brand new versions of them, or we saw them in different areas of the application, right, in new areas of the application. We'd never seen it before. And this allows us to quickly get and start understanding and start taking action, right, whether it be automated action, or whether it be manual intervention. Again, you might not trust us right away, and that's perfectly fine. So again, go to a manual interaction where you can choose what to do. But once you start trusting Harness, you can actually start automating the response. So how do we do this? Because this gets a little trickier. right? It's not just a time series data. It's not something that I can quickly chart. I can put up on a few models. Now I have to do some real big digging, right? Because I don't want to bring all this data also. I don't want to bring every single log you have back in a harness. There's no point in that. You already got them sitting in a whole bunch of different places. So I need to make sure I only grab the things that are different. And then for that, we start with entropy. And we really start understanding, where's the difference? And if you look at the string, it's mostly ones with a single zero. Well, the thing that I want to look at is not all the ones. Those aren't interesting to me. I really want to look at that zero. I want to look at the thing that's slightly different that I can now start digging my teeth into, understanding it doesn't look like it's normal. After I start calculating entropy and I start separating them in distance and I can see how far apart they are, now I can start taking those and I can actually start clustering similarities. So now I can start using k-means clustering and I can actually apply the clusters to make sure that we know where these reside together. Right? And clustering is great, but it doesn't give us all the information. It doesn't give us all the information because of how exceptions can be different. Like I said before, and I talked about it just briefly, when we talk about exceptions, right, they can be a multitude of different combinations. Right? They can be the same exception, and it could be in a different part of the code. Or like I said, it could be a different exception in a different part of the code. Or finally, it can be a different exception in the same part of the code. So that same part of the code, that same class can have multiple exceptions it's throwing. Each one of those exceptions are actually different. And so one thing you'll notice that we're looking at both Jacquard distance, right, as well as cosine. So we're looking at similarity and difference. And why does that matter? Well, I have to see how similar the actual exceptions are, right, see if they're real exceptions. But then I have to see how far apart they are in the actual application code. Understanding, are they in a different class? Do they reside in a different area? And now I can't just do one individual calculation. I have to actually apply them both. So again, I have to apply entropy, give myself some clustering. Once I get clusters, now I have to actually see where in those clusters. Are they in the same part? Are they not? Are they the same exception? Are they not? What's interesting, I've described to you a massive amount of machine learning models. However, your brain can do this instantly. And again, it's building models that make sense in a human context. And this is what's giving us benefit. All right, we'll give an example. We'll show it visually. If you guys have any questions, go ahead and throw them in the chat. When you think about it, I've got an application log. It's got 100 events in it. Of those, 10 of them are NPEs, right? Of those NPEs, they're actually thrown in different parts of the application. So I can't show this as just one individual NPE. I have to show this as 10 separate NPEs because they're all thrown in a very different place in the application, right? All the different classes, all the different packages. And so now, yes, I've got all my different exceptions. I've got all my class not founds, right? Now I got my NPEs. And where traditionally we can just kind of aggregate them all as one, they're not actually the same. They're very different because they occur in different parts of the application. And this is going to allow us, again, much easier troubleshooting. So we have to call them out as 10 individual ones. If, however, say those NPEs only came from 3 classes, now instead of seeing 10 individual markers and understanding those exceptions, we'd only see 3. We'd aggregate them up, understand it's only in 3 classes, it's the same NPE, in 3 different classes, and we'd aggregate them for you. And again, being able to think about it in that same capacity as a human. So where does this break down? Right? This breaks down in things that humans know. So anytime that we go look at a UID, a URL, IP addresses, like cookies, anything that has, meaning to a user or to an account or something to the effect of, well, now, if I use k-means clustering and I use natural language processing to look at these 2 similar logs, they would tell me that they're very different. Right? However, you and I both know it's not a different error. It's just a different user that's creating the same error. So now, this is where the machine learning models break down. Right? All of that thing that we just built, all of those pieces of information that we're trying to aggregate and understand, now it breaks down because the machine can't tell the context that a human can around all the things that we know are unique and the things that we know we have to ignore in order to calculate similarities. So how do we deal with that, right? So when we first built these models, 2017, I think it was, it got quite interesting because we had this great idea. We're going to use all this machine learning. We started doing it for all that performance data, which was awesome. And then we're like, throw it on, let's throw that same ML. We use all that ML, we'll do it for the log analysis. And what happened was we got a massive amount of false positives. As you can imagine, every time I showed a different user, a different piece, and our customers like, this isn't valuable. I'm looking at 1,000, events that should be quote unquote an error, an exception, but they're not, they're the same. And this is where we had to start building neural networks to truly think about things in the same context. So understand that an account ID, a URL, those are unique in the sense that they're differentiating, who's actually using it, but they're not unique in the error, the exception. So again, we had to build a neural network using all the data that we aggregate to understand what this looks like and then be able to apply it in real time. So now it can have, again, that same context that a human does without even now having to train it. It gets smarter and smarter every time it sees more and more data. Good example of this one, and then we'll move on to some CI pieces, which will be fun, and then we'll try to open up for some Q&A. So Build.com, if you guys aren't familiar with them, they're like a Home Depot, but they're entirely online. They're the second largest home goods store in the United States. Not as relevant to everyone in other countries, but you can go with me. It's a retailer, so if they're down, it costs money, right, and lots of money. So the example here, what we'll talk about, this is one of their production pipelines that they were deploying to. It's multiple stages, going from CI to non-production environments, getting ready, got approved to production, and actually went to production. What's interesting about this is it absolutely failed in prod. And that's not good necessarily, usually. But what they'd done is they've fully automated this. So they did just what we talked about, which was automate everything. And so now what would happen? After the deployment, we go verify, we go test all of the things that we want. And these two use New Relic and Sumo Logic. So again, an APM tool and a log analyzer. And what was amazing is literally Harness caught issues that they had. And I've got it blurred out, but this is in their checkout counter. Can we imagine what happens if our checkout counter doesn't work in a retail situation? If I can't check people out, I'm unable to make revenue. It's our most important microservice we have. And this is where understanding that is important. But being able to take action is actually more important. So they emailed us letting us know, hey, this happened. And here's the coolest part about it. Harness automatically took action and it rolled it back. And if you look here, it actually rolled it back in 32 seconds. This is a traditional deployment, Tomcat, SSH on the boxes. It used to take people, once they determined what the problem was, almost 30 minutes to roll back. That's 30 minutes of lost revenue. And instead, 32 seconds later, after it was noticed, Harness got it right back to where it was without having to write a single line of code because it knew what was deployed on which infrastructure, with which configuration, and which secrets. Gets kind of interesting, right? Now we start contextualizing how you can actually use this and really start automating it. One of the things I talked about was, in continuous integration. I know everybody loves sitting there waiting for their builds to run. I know everybody loves waiting for the tests to happen. It's our absolute favorite thing. I drink more, well, Monster usually than coffee, but I'll take my Monster breaks for that. And I'll just wait for it to compile. The interesting thing is it doesn't make much sense, right? And if we think about it, right, massive surveys on what is literally the most time wasted in any part of software delivery. And through every single survey, in every single thing, we always see testing, right? The testing process takes a massive amount of time. And this is what holds up our software delivery. And why? Because we don't want to release bad code. I genuinely, at my heart of hearts, do not want to do something bad for the company. I don't want to impact it negatively. I do want to make sure my tests run, but man, does it take a ton of time. And if you think about it, it's actually how we do it. It's quite archaic. I'm going to go back to cars again because the reality is if we think about it in cars, we wouldn't do anything like this. So hopefully everybody knows what a car is. We're gonna go with that one because if not, you missed the whole beginning of the presentation. Secondly, hopefully everyone knows what a gas cap is. I got a picture of it here. And if you've ever had to replace a gas cap, it's not a huge thing, right? Take it off, put a new one on, tighten it on, no big deal. But here's the question. If your gas cap's broken and you replace your gas cap, would you go and literally test every single electrical system and mechanical system in your car after you change the gas cap? Hopefully no one says yes, but if they do, please put in the chat. I'll absolutely have that conversation with you. The reality is I can understand testing the fuel system and things regarding fuel, and I can make sure that it's going to start. But testing every single light, testing every single piece of electronics, when you only affected a small portion of the vehicle, just doesn't make sense. But think about what we do today. If I make one line of code, if I change one single line of code, I am going to test every single unit test I have. I'm going to test every single integration test. And why? We're intelligent enough to know what we change. We can go and actually inspect the code and understand where those changes were, what they affected, and ultimately only test what you should. And this to me is mind-boggling. Again, why would we sit there wasting time? And not only time, money, right? Most people are spending massive amounts of money on their non-production infrastructure. Because of all those tests that have to run, because of all the concurrent builds that we're doing, we have massive sink in all of those costs on non-production infrastructure. So again, when we think about it, I might have 1,000 tests that I need to run, but the reality is because I only changed a small portion of the code, I can probably skip a whole bunch of those. And the idea, honestly, is I should only run tests against what's changed. And more importantly, I should run them in order. If we have a test that's flaky, or if we have a test that constantly fails, why are we waiting to the end? Let's think about this like our best engineers would. Why don't we run those first? Right? Fail fast. Let's get them in order. So let's reorder them. Let's make sure that when we do execute them, we execute them in a way that's meaningful. If we write a brand new test, we've never seen a result for it, we probably want to run that first. Right? If you change a test, right? Now we don't know what to expect, so we should probably run that first. And again, if you haven't changed anything in the code, why go test it? Now, you might say for regulatory purposes, I have to, Nick. We have to test everything for our big master builds. Fine, but on every single PR, why are we doing it? So then on your master, you can say, you know what, just run every test and that's fine. But the intention is, why are we sitting there wasting those cycles, wasting that time, testing things that we know we don't have to? We wouldn't do it on our own vehicle. We wouldn't do anything we do in normal life. Let's think about it like our best engineers again, and really start applying that machine learning to intelligently test what we're going to do and bring down those times, ultimately bring down those costs, especially if you make that infrastructure ephemeral. I hope you guys have enjoyed this presentation. I've got, I think, 2 slides left, and really it's to talk about, kind of where you're at in your software delivery journey. We're going to put out another poll. I think maybe we can do that. There it is. Oh, look, I even got the poll. Heck, I'm gonna click on the poll just for fun. All right. So this is probably doesn't make sense yet. So we'll talk through the velocity, the governance, the quality, and efficiency, and you can kind of, as you go through, we can see where we end up. But I think everyone's journey starts with velocity, right? And what I mean by that is we want to go faster because our CIO, our CTO, somebody said that we have to deploy faster, we have to keep up with competition, and we have to go faster. And what we usually do is extend our CI tool or use a whole bunch of open source software, which is great. And then what we find is that might have been easy, and we might have gotten up and running and got it going, and then it starts getting cumbersome because now we own a whole bunch of scripts, or more importantly, now we have to actually govern it. Right? Now we have to spend some time making sure that we know what good looks like, and that we're actually making sure that it meets our compliance measures and it's audited, and then it applies the appropriate robust access control, and we can actually standardize and understand that people are doing the appropriate deployments, and they can't deploy to production if they're not allowed, or they can't do it without a separation of duties and meet all those requirements. And that becomes hard. And so a lot of people struggle when they're reaching velocity and then they're starting to apply governance. If you've been successful at velocity and governance, the next problem that people hit, because if you do that, now you're reaching your velocity goals. So we're deploying n times n faster, right? Our monoliths are turning into microservices, and we're deploying n number of times faster every day. So now, like I said earlier, there's not enough people in the NOC to understand what good looks like. Like, they have no idea what broke what. We're deploying so fast, making so many changes that I just can't tell. And this is where we have to use machine learning because, again, humans just can't scale. And if you can achieve velocity, governance, and quality, and this is hard to do, but if you can, the next thing that happens is traditionally efficiency issues. This might be because we're not giving the developers all the information they need to be efficient. Are they getting the costs to their servers? Are they understanding what that extra memory that they're asking just to make sure their app doesn't break what that's costing the business. So they're understanding what the CPUs are. Are they shutting down their infrastructure in the evenings or when they're not using it? Are they bringing it back up on demand? All of these things now start creating costs that, again, traditionally we haven't even given that information to the people who can actually affect change. And Harness is here through the entire software delivery journey. So no matter where you're at and what you're doing, this is where we're here to help. So this might be to help you start going fast and to create templates that you don't, we can be dry, don't repeat yourself. This also might be that after you've created that velocity approach, now we have to govern it. And Harness is built with full secrets management, audit and compliance and role-based access control. It's been built from the ground up for every single compliance need on the entire planet. I've yet to lose one. We've got them on almost every continent. I don't think we're in Antarctica yet. And so hopefully we won't be. But the intention here is to apply all those governance rules and those standards and those quality gates and those security checks to make sure they're templatized that people can't deploy. And then ultimately, when it comes to the quality, we talked about how we use the machine learning to actually bring that up. And if there is problems, affect change for you. And in the efficiency, this is where we give you that visibility to the engineers. We truly shift left, give them visibility, allow them to make better decisions, give them not only visibility, but also give them recommendations. And then even for that matter, allow Harness to take action. So we can start saving costs dramatically right away, bringing that down across the board. All of this is really, when we think about people, process, and tooling, or people, process, technology, apologies for that louder noise. I think this is, it's interesting because it actually comes, hold on, let me hang up that phone. Apologies for that. When I think about it, when we want to deliver this, it's actually not about people, process, or technology. It's entirely about confidence. If we're confident that our people will do the right thing, or if they have a process in place that will allow them not to do the wrong thing, then we can have complete confidence in their ability to deploy meaningful code into production when they're allowed to. And again, Harness is just that tool that allows you to apply that process throughout the entire life cycle, so that you can have confidence in every single one of your developers, every single one of your engineers, every single one of your ops team, to make sure that they're doing the appropriate thing at the appropriate time. Lastly, Harness started life as continuous delivery as a service, and we decided to build continuous delivery first because everybody had extended CI, and we took the idea that CI was solved, everybody's got it sorted, Jenkins is great, and we said, let's solve continuous delivery because that's the hard part. A lot more variables, a lot more different moving parts, moving pieces, all the regulatory, the governance pieces. What we realized is we wanted to take that AI and that ML and we wanted to use it across the board. And we figured out very quickly that our customers told us that CI wasn't solved. It still needed some help. And again, that's why we applied all that AI and ML to the CI side as well. So we acquired the most loved open source CI tool called Drone. And instead of killing an open source tool, we 4X'd its employees. We massively invested in the open source, giving it a brand new UI refresh and a whole bunch of new functionality to the open source. What we then did is offered an enterprise version which wrapped all of our governance, our compliance, our security, and our modeling around it. So to give you all of that, again, AI and ML throughout every piece of this. We thought as we deployed software, we always used our own feature flagging tools to make sure that our customers got what they needed and only got what they needed, and they could validate it and verify it and test it. And then once they accepted it, we'd give it out to a larger audience, and then we'd ultimately deliver it as a GA product. And our customers asked us for that same thing. So we released our feature flagging model to do the exact same thing and still use that ML modeling to be able to understand when I flip that feature flag, does it look okay? Is that customer being impacted accordingly? This stands true for change intelligence, which is coming soon, which is now not about your deployments, but when you say, switch that network, you make a change to your network, or you adjust the database, you want to apply that same understanding of looking at all of the metrics, looking at all of the logs, and understanding what normal looks like, so you know what was changed, and you can also get back to where you were. And then lastly, in cloud cost management, most people would say this isn't part of the software delivery lifecycle, and I believe that it is. I believe that it should be, and I don't believe that it's currently being put that way. Today, our engineers aren't given the visibility to understand what they're deploying. They have no idea what the costs are incurring to the to the larger team. And it's a broken process where the CFO comes and kicks back a bill, 30 days later, and you got to figure out why it's broken. As opposed to, as engineers, we honestly would do the thing that's right out of the gate if we have the data. I'm not going to go do something malicious. I'm not going to go charge the company $50,000 extra because I want more memory. If I don't need it and I can prove it, I'll always bring it down. And that's exactly what we want to do. The other part of this is being able to auto stop that infrastructure that honestly we talked about, which is all of that non-production infrastructure that runs usually 24/7. And we might be able to shut it down with some schedules, but instead, again, think about it like a best engineer would. Let's look at the two things that show us the system's being used. Do we have batch jobs running? Do we have processes running on the system? Or do we have network traffic coming to it? And let's put a load balancer in front of it. And we don't see that traffic and we don't see its processing. Let's automatically shut it down. And more importantly, when we bring it back up, let's put it on the most efficient or the cheapest instances. Let's throw it on spot instances for you. And let's also automatically move it from spot instance to spot instance for you if you're in your non-production environments. All this, again, is designed to be here for you in a capacity that's extremely modular. So use only what you need to use. Don't go and grab all the parts and pieces if you don't need them. Integrate with all the tooling that you already have. If you've got competitors and the feature flags, you've already solved CI, great. Let us help you in the area that you need. And apply that AI and that ML, right, to, again, make your engineers' jobs easier, to make your operations teams easier. With that, I think I'm done. Time for questions. Hopefully I didn't bore anybody. If I did, for that I apologize. But love to get any questions.
Excellent. Okay. Right now we have one question, but before I get to that, I just want to remind everybody that if you would like to submit a question to Nick, you can go to the Q&A section and submit your questions there. One question here is, how many large customers currently license Harness?
Great question. So we have just over 400 customers that are paid production customers. So we offer like a team version that's free to use, but as our actual paid customers, it's just over 400.
Excellent. Second question, how long do the ML models take to become effective?
Ooh, good question. I didn't cover this during the presentation. So one of the things that you think about is all the things I talked about are great unless it takes you forever to start leveraging those models. So if I said it took 6 months, you'd be like, well, that's a waste of time. And the good news is it doesn't. We talked about the control and the test. And so the idea here is that it actually starts providing value on the second deployment. So the first time that you deploy, it's going to create those baselines. And the second time is when we're going to actually be able to compare and start driving value. So to answer that question, second deployment is when you gain value.
Excellent. Another question here. Does Harness have any mainframe capability?
Great question. So one of the things I didn't cover is Harness allows you to deploy what I call where you were, where you are, and where you're going. And so that means, old traditional legacy technologies, if you wanted to use things like mainframe, or if you're SSHing into boxes and deploying, old WebSphere, WebLogic technologies, if you're, sitting on Pivotal, right? If you're cloud native or if you're Kubernetes native. So really all of those areas. What I will say is this, is with mainframe, since you guys have probably been doing it for, I don't know, ever, since the dawn of time, you probably have a pretty good setup and a system to deploy those. And IBM's got a ton of tools there. If, however, that's your pain, yes, we can help. But usually what I find is most often it's in the, we'll call more modern technology, things like a Tomcat or a JBoss or WebSphere, where the automation doesn't exist as well. And then, of course, all the cloud native, say Kubernetes and container native technologies. But the answer is yes, you can also use Harness to script anything you want, but I would be very clear, do not use Harness as a scripting engine. It's way too expensive for that.
Understood. And we still have a little bit of time for questions, but for now, I just want to remind everybody that today's webinar has been recorded. So if you missed any or all of the webinar, you will be able to watch it again. We will be sending an email with a link to access the webinar on demand. The webinar will also be available on devops.com. Just look in the on-demand section of the webinars page, and it should be there. Still not seeing any questions?
Perfect. Well, I want to thank the devops.com team for having us here, and genuinely all that attended. Thank you, and for your interactions and your questions and answering the polls. Genuinely appreciate it. there's more that we can do to help you, please reach out to us. Again, you can go and actually just start using it if you want, but we can also help you throughout any of your trials, your process. So reach out to us at harness.io.
Excellent. Excellent. Thank you very much. Just to get the Amazon gift card winners, our first winner today is Dennis D. Congratulations, Dennis. Our second winner is Larry M. Our third winner is Milton H. And our final winner is Janet R. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, please check your spam folder. Nick, thank you very much for taking the time to put together this presentation. Really hope everybody enjoyed it.
Absolutely. Thank you. Please give your feedback, good, bad, or ugly. I don't mind hearing that it was horrible. So please let us know. I always want to make it better. So hopefully it was enjoyable.
Okay. Thank you, everybody. This is Julio Godinez signing off until next time. Be well.